What if the sun, the thing that powers life, became a massive threat to modern civilization? I'm not talking about in billions of years, but next week, or even tomorrow. Solar storms have the ability to knock out satellites, scramble GPS, and with the most extreme examples, called coronal mass ejections, or CMEs, they can even collapse our entire power grid. Today we're breaking down how that happens, from the physics to the protection plans, and how likely is that nightmare scenario to happen. I'm Ben, this is Physics or Bust. A solar storm is basically the sun losing some of its mass by ejecting it into the solar system. The most extreme type? Coronal mass ejection, or CME. A colossal bubble of charged particles with magnetic fields hurled into space at speeds of up to 3,000 kilometers per second. When these ejections are aimed at Earth, they can slam into our magnetic field in just 1 to 3 days, and that's where things get dangerous. We'll dig into the physics in a minute, but first, if you like this video, you'd probably like this book. I've got a link in the description below. I do get a small commission, but it wouldn't cost you any extra. Now, in their small CMEs, they can create a really cool effect. That's called the Northern and Southern Lights. And to be fair, not all CMEs are fully dangerous. The Earth's magnetic field does protect us from them. So how does this mess with our power grid? Here comes the physics. As a CME comes close to Earth, the magnetic field produced by all those charged particles in the CME start to compress and distort the magnetosphere, Earth's magnetic shield. The interaction between the Earth's magnetic field and the magnetic field produced by the particles of the CME create a rapidly changing magnetic field. And we know by Faraday's law of induction that changing magnetic fields induce changing electric fields, which produce an electric current in the ground as well as conductive materials near the ground. These geomagnetically induced currents, or GICs, flow through power lines and transformers. But here's the kicker. Grid infrastructure wasn't built to handle slow DC-like currents over hundreds of kilometers. These currents can overheat transformers, trigger protective relays, and even cause cascading blackouts. And I'm not talking about just blacking out a city. I'm talking about blacking out entire continents. Think about it. Wires meant to conduct electrical power do just that, but in a destructive manner. And despite what some people hope, this isn't sci-fi. In 1859, the Carrington Event triggered auroras as far south as Cuba, and that's not all it triggered. Telegraph systems caught fire, telegraph operators even got electric shocks. There was so much power going through the lines that some operators disconnected from their power supply and still were able to transmit messages. And more recently, in 1989, a smaller CME hit Canada's Hydro-Quebec grid, knocking out power to 6 million people in just 90 seconds. And that one is considered mild compared to what the sun can do. NASA and NOAA say there's roughly a 12% chance of a Carrington-level event hitting Earth in the next decade. That may not sound like much, but it's higher than the chance of your house catching on fire. And unlike wildfires, hurricanes, and tsunamis, a major CME could affect every country on Earth simultaneously. Some researchers argue we're actually overdue for a Carrington-level event. And with solar activity right near its peak, since the solar maximum is this year, I'd say that increases our odds pretty drastically. Add to that the fact that the Earth's magnetic field is actually weakening as we get closer to the magnetic pole shift. And that means we don't even have to have a CME the level of the Carrington event in order to have the same effects, triggering massive cascading failures of power grids around the world. So how do we protect something so massive and fragile from the wrath of the sun? Thankfully, we already have some eyes on the sun. Satellites like SOHO, Discover, and NASA's Parker Solar Probe monitor solar activity in real time. They can detect the early signs of a CME, giving operators an extra 15 to hour more to prepare. That's not a lot of time, but every bit helps. Then they'd be able to do things like powering down transformers, isolating sections of the grid, and managing the electrical load to reduce damage. But this only works if power utilities are trained, coordinated, and take the threat seriously. The best protection we have from losing our power grid is prevention. That means physically upgrading the infrastructure, installing GIC blocking devices in order to filter out the harmful currents, replacing aging transformers with resilient grounded devices, and creating redundant circuits so that no single failure results in a regional collapse. These fixes aren't theoretical. We have this technology right now. Governments and utility companies both know about the risks. In fact, the U.S. Department of Homeland Security has called a major geomagnetic storm a low-frequency, high-impact threat. And the National Academy of Sciences has even warned that a major CME could cause trillions in damage and take years to fully recover. So why the inaction? That answer's pretty simple. Grid hardening is expensive. The threat isn't predictable, and frankly, it isn't politically flashy. It's easy to fund new highways, something that's readily seen and can make a daily impact on. It's much harder to justify invisible insurance that nobody's really gonna see against a cosmic storm that'll happen at some point in the future, but with no certainty on when. Even when protections are included in legislation, like the U.S. Grid Reliability and Infrastructure Defense Act, GRID Act. They often get delayed, defunded, and even weakened during implementation. Meanwhile, the most vulnerable parts of the grid, like large, high-voltage transformers, remain at risk. And these are custom-built, often imported, and can take over a year to replace if damaged. Let's say a Carrington-level event hits Earth tomorrow, and we're not prepared. Here's what'll happen. Within minutes, long-distance power lines begin conducting destructive currents. Transformers start overheating and fail across regions, especially near northern and southern latitudes, where the magnetic effects are the strongest. Within hours, millions, and potentially hundreds of millions, of people will lose power. But the scary part isn't the blackout. Most people can handle a few days without power. It's the recovery. Restoration would require global coordination. Replacement parts are few and manufacturing is limited. Affected regions would likely be without power for weeks, if not months, with some industrial sectors crippled for years. And that's not just lights and internet. It's water pumping systems, medical infrastructure, refrigeration and food supply lines, even national defense and finance systems. The fallout from a grid collapse would look less like a power outage and more like a systemic breakdown of modern civilization. So when someone mentions they'd love to see the Northern Lights, let them know that eventually we'll have a CME that will let them see it all the way down to the equator, but when they see those lights, don't expect the lights on your house to be on. What do you think it would take to get governments around the world to invest in infrastructure? Let me know in the comments below. We know what needs to be done. The technology's already here, we have the tools, we have the physics. What's missing is the urgency and the investment. Until then, we're just rolling the cosmic dice every time the sun gets a little too active. For more science and tech news and updates, remember to like and subscribe, and remember, keep asking questions. See you in the next video.